Alright, boys and girls, today's lesson is lesson 7-4, equivalent fractions using multiplication. And this should be somewhat familiar because we've been talking about this a lot in class, even before this lesson, even before this unit. But the first thing I want to do is I want you to turn to page 237. And we're going to walk through this, and I'm going to kind of teach the lesson as we go through these pages. There's 4 pages. I doubt we'll get to all 4. Maybe we'll only get to a couple, and you can finish the rest on your own. But I'm going to try to do a little bit from each. Alright, so it says, Lewis works summers at Maria's fruit farm. One day, Maria agreed to give Lewis extra pay if he could sell 2/3 of her supply of peaches. They started with 12 bags of peaches. Lewis sold 8 of them. Lewis said to Maria, 8 bags is 8/12 of the bags you wanted to sell. I think 2/3 is the same as 8/12. I can show you why. Lewis made this drawing. Did Lewis earn his pay? Well, what he did is he broke up a whole into 3, and then broke up a whole the exact same size into 12. Okay, and then what he did with the 12s, he found out how many 12s he got rid of, which was 8/12, and then he compared it to the 2/3 that she wanted him to get rid of, and as you could tell, they take up the same amount of space, so they are equivalent fractions. There's another way, because we talked about equivalent fractions using multiplication. If you take 2/3 and you multiply each by 4, you get 8/12. And that's what that is. So this is another trick we learned earlier, so that should be pretty easy for you. Okay, so it says 2 fractions that represent the same part of a whole are equivalent fractions. We did it yesterday with the number line. The fractions 2/3 and 8/12 are equivalent. Maria said, you are just fracturing each third into 4/12. You can show what you did using numbers. Here's what Maria wrote, and that's kind of what I just showed you. Maria talked about how she took the 2/3, multiplying each by 4 to get 8/12. So how does multiplying the numerator and denominator by 4 affect the fraction? Okay, well the answer here is it changes the way the fraction looks. It doesn't change the amount. It's still the exact same amount. It just changes the way it looks. So in this case, if you multiply each of them by 4, because 4 over 4 is really 1. So you're taking 2/3, and you're really multiplying it by 1. But you know 2/3 by 1 times by 1 is 2/3. But if you make that 1 look different, and you make that 1 into 4 over 4, that way you're doing 8. 2 times 4 is 8. 3 times 4 is 12. And you get 8/12, which equals the exact same. It just looks different. Alright, let me push this aside. Turn to the next page. This is using fraction bars to find equivalent fractions. Kind of what we just did in the prior page. How do these fraction bars show equivalent fractions? Well, equivalent fractions for 1/3. How does it show it? Well, these fraction bars all have the exact same amount. Imagine a candy bar. And the way it's broken up. 1 into thirds, 1 into 6, 9ths, 12ths, 15ths, 18ths. And the first one you get 1 out of the 3, the second one you get 2 out of the 6, third one you get 3 out of the 9, 4 out of 12, 5 out of 15, 6 out of 18. They are all equivalent fractions. They take up the same amount. They are the same amount, the same amount, but they just are written differently as fractions. So number 4 says you can show how to find fractions equivalent to 1/3 numerically. Fill in the blanks and finish the equations. Then explain how these fraction equations show equivalent fractions. The first one did it for you. It showed you 1/3 times 2 over 2, and then you could go 3 over 3 and 4 over 4 and 5 over 5 and 6 over 6. Really, you're multiplying it by 1 every time. This gives you 3/9. This gives you 4/12. This gives you 5/15. This gives you 6/18. So you multiply it by 4 equal parts, 5 equal parts, and 6 equal parts. I don't know why I'm writing in pink. I can't imagine that looks great, and I can't imagine it being easy on your eyes. What it means by 4 equal parts, 4/4, that equals 1, but that 1 is broken into 4 equal parts. Here, it's broken into 2 equal parts, 3 equal parts. Here, it's 5 equal parts and 6 equal parts. Same thing. If you had a pizza and it wasn't cut up at all, and you ate the whole pizza, you ate 1 out of the 1, okay? 1 whole. and you cut it into 6 pieces and you ate all 6 pieces. You ate 6 of the 6. You still ate the whole. It's just a different way to look at it, a different way to see it. Number 5, tell whether the fractions are equivalent. Okay, my way of finding this out is, well, let's see, how does 1 become 2? That's what I like to look at first. 1 becomes 2 because you multiply it by 2. If you multiply the top by the 2, you must multiply the bottom by the 2. Is 6 times 2 equal 12? Yes. So this is correct. Next one, how does 3 become 5? Well, and 6 become 9. Well, if you look at it, you'll see that 3 really can't become 5. You can add 2 to it, but that right there is a warning sign that should make your eyes light up and say, oh, hold up here. This one, I don't like how this works, because if you look at the bottom 2, 6 really can't go into 9. So because of this, you know that it is not equivalent, so no. And the next one, 6 and 8 and 12 and 15. Well, there's ways to look at it. Can 6 go into 8? No. Can 12 go into 15? No. What are some other ways you could make this look? You could make the 8 and cut it in half, give you 4, and then you get 15 cut in half. Really doesn't work. So I mean, you could sit there and work on it all day long, but at the end of the day, you're gonna say, you know, these are not equivalent fractions. You could also draw out a candy bar and break it into 15 pieces, and take another candy bar and break it into 12 pieces, and then take 6 of them and 8 of them. And that right there would tell you, when you get down there, it'll be no. But just by looking at this, because you know 6 can't become 8, 12 can't become 15, it just doesn't work. So we'll get that page out of the way. We still have a lot of time left. We're flying through, and a lot of why we're flying through is because I know we've talked a lot about this. So this is good. This talks about using a multiplication table to find equivalent fractions. The table on the right shows part of the table on the left. So what it's doing is showing this, but without that. Okay, none of that row. It says you can find fractions equivalent to 1/3 by using the products in the row for the factors 1 and 3. Okay, so if you do the factors 1 and 3, and say you want to times it by 6 equal parts. So if you do 6 equal parts, you would take 1 times 6 and 3 times 6. And if you look in your multiplication table, you take the 1 and times it by the 6, you get 6. And the 3 times it by the 6, you get 18. And it's almost as if they're right above each other, because they would be in the same column. You get 6/18. Also, because of the whole fact triangle, the whole family that you do here, when you have 18 on the top and you have 6 down here and 3 there, it's a family. So because you are multiplying, you can also divide. If you have 6/18, if you want to go backwards, if you want to go the smallest fraction you can get, the smallest looking fraction, because they're all equal the same, you can divide each by 6. You get 1/3. Okay, so if it's a bigger number and you want to make it smaller, you use division. If it's a really small number and you want to make it bigger, you use multiplication. So, and here's a fraction bar showing the 1/3 and 6/18. They are equal to each other. All right, so I don't want to continue doing everything for you, and I know this is helping you, but I'm going to do one of these here, and then I want you to do the rest. So how does 1 become 4? And if it becomes 4 a certain way, then it must work the same way for the denominator. So 1 times 4 would equal 4. Does it work for 3 times 4 equal 12? Yes. And I'll do one more for you. How does 1 become 9? Well, that's easy, 1 times 9. But before you write in, you want to make sure that 3 times 9 also would equal 27. In this case, it does. So you should be able to do the rest of these on your own. Once again, at the bottom, you're going to think of ways of how 3 becomes 12, and if it does work, then does it work the exact same way for 4 to become 16? How does 1 become 5? Does it work for 2 becoming 12? And then how does 9 become 90? Does it work for 10 becoming 100? I want you to work on those on your own. When you're done, I want you to actually don't do this page yet. I'm sorry. I want to go to the next page and quickly look at that with you, and then you can go back and finish everything up. Puzzle Penguin said, I tried to find a fraction equivalent to 2/3. Here's what I wrote. He wrote 2/3 equals 5/6. Is my answer correct? If not, please help me. You should know by our whole multiplication on the top and the bottom as being the same. You should know why this is right or wrong. So I want you to write a little response in there why it's wrong. And then here it says find a fraction equivalent to the given fraction. This is just practice. This is, you can do whatever you want on this, whatever you want. Use any number for 14 through 22. So what I want you to do now is I want you to go back and grab the last page. I want you to work on 239 and then work on 240. And we'll continue this in a small group.